Today's video is going to cover learning target 1E, which is solving equations with variables on both sides. There are basically three steps to follow when solving an equation with variables on both sides. First step is to simplify or combine like terms of the expressions on each side of the equal sign. You'll notice when I get to the problems that follow, I like to divide the problem in half at the equal sign, look at each side independently, and simplify each side before I start moving things from one side of the equal sign to the other. So that first step is just simply to combine those like terms on each side of the equal sign. After you combine those like terms, then it's easy to start moving from one side of the equation to the other. So that second step is to combine the variables. So move all the variables from one side of the equation to the other so that they are all together on one side. And then that third step, once you do that, it will look just like a one or two step equation which you studied and learned about in the previous video. Before we get going on actually looking at some problems, I remind you of the golden rule of algebra, which is to do unto one side of the equation what you do to the other. Always remember, whatever you do to one side, you have to do the other in order to keep it in balance. Let's start looking at some examples. First one we'll look at is 7a minus 17 equals 4a plus 1. In this case, there's nothing to simplify, so we can just go right ahead and start moving from one side of the equation to the other. So first step is to combine all your variables onto one side. So in this case, I'm going to take the 4a from the right side, subtract it over to the left side in order to combine those. When I do that, the 4a's are eliminated on the right, and I'm left with 3a minus 17 on the left equals 1. Now I'm going to start working in the reverse order of operations in order to isolate that variable. So I'm going to add 17 to both sides. I get 3a equals 18. Last step is to divide by 3, and we get that a has to equal 6. Now in this case, we were able to skip that first step because each side of the equal sign was already in simplest form. In this case, though, we're going to have to do some combining of like terms and simplifying. So I go ahead and I divide my equation in half, so I look at each side separately. On that left side, I notice that I can combine the 5 and the negative 2 to create a 3. So I have 3 minus x. And on the right side, I can combine the 5 and 3 to make 8. So I have 8 plus 4x. Once I do that, I am now ready to start moving my variables from one side to the other. So I'm just going to add my x over to here in order to eliminate from the left side. I get that 3 on the left equals 8 plus 5x on the right. Subtract my 8 over to the left side of the equation. And I get that negative 5 is equal to 5x. Divide by 5 on each side to get that x by itself, and I get that x equals negative 1. Now this is the first instance where we're going to see the distributive property. Anytime you have an expression inside of parentheses that you can't combine, you're going to have to use that distributive property. So my first step here to simplify is I'm going to distribute that 6, which means I'm going to multiply that 6 by the x, and I'm going to multiply that 6 by the 7 inside the parentheses. So when I do that, I end up with 6x plus 42, still minus 20, and that's still equal to 6x. Now I'm going to continue simplifying that left side, noticing that I have a 42 and a negative 20 that I can combine. So I have 6x plus 22 now is equal to 6x. Subtract 6x from the left side to get them all together on the right side. And here I notice that 22 is equal to 0. Now I know that 22 does not equal 0. Hopefully you know that 22 does not equal 0. So that should put up a red flag. Since we know that 22 does not equal 0, we know that there cannot be a solution to this problem. Anytime you get that situation where at the very end you get two numbers that are not equal, saying that they are equal, you're going to end up with a no solution. That means that there is no value that you could plug in for x that would make that initial equation true. Let's go ahead and look at another example. So once again here I have a distributive property that I'm going to have to use. So in order to simplify, we'll start by distributing. So I'm going to multiply that 2 by the x and 2 by the 4, which gives me that 2x plus 8. Still the minus 5 on the left side, and that still equals 2x plus 3. Again, I can simplify that left side a little bit more by combining my 8 and my negative 5, which gives me 3. So now I have 2x plus 3 is equal to 2x plus 3. Subtract my 2x's to get my x's together, and now I end up with 3 equals 3. Now in the last case, we knew that 0 did not equal 22, but in this case, we know that 3 does equal 3. So since that's a true statement, I know that any value I plug in for x would make this statement true. So my answer would be all real numbers. Any number I plug in for x would make this statement true. Let's go ahead and look at one more example. So in this case, hopefully you've noticed that I'm going to have to use the distributive property on both sides in order to start simplifying each side of this expression. So I'm going to go ahead and distribute the 2 on the left, and I get that 4t minus 6. Distribute the 6 on the right side of the equal sign, and I get 6t plus 12. Now I'm going to go ahead and start solving since there's no more simplifying to do. So I subtract the 4t on the left to get all the t's onto the right side. And I'm left with negative 6 is equal to 2t plus 12. Now it's just like a two-step equation. I'm going to subtract my 12 over to the right side. I get negative 18 is equal to 2t. Divide by 2 to get that t by itself. And I get that negative 9 is equal to t. So you've noticed in all the equations that we've worked on before, in one case we had no solutions. In one case we had all possible solutions. And in a couple cases we had just one unique solution. Here are a couple practice problems for you to look at. Go ahead and pause the video while you work through this so that you can not be surprised by the answer, which will be on the next screen. As you can see, problem on the left, when you work through it, I'm going to start by moving my x's from one side to the other. I should note, and I should have said this earlier, that you can move the x's to either side of the equal sign. Okay, you've noticed that sometimes I move it to the right side, sometimes I'm moving them to the left side. Either way that you move them, you should still get to the exact same answer. So it doesn't matter where you move those variables. So in this case, I subtract my 2x to move it to the left, go through the two-step equation, add my 3's, divide by 2, and I get that x equals 1. On the right side, I'm going to have to use the distributive property on both sides, then combine my x's. That gets me to a two-step equation, so I subtract 35. I get that 14x is equal to negative 70. Divide by 14 to get that x by itself, and I get that x equals negative 5. Now, in class, we've already worked on one-step equations, two-step equations, and equations where variables are already on one side. So I encourage you guys to continue practicing with variables on both sides. We will start working on these tomorrow in class. So please come with any questions.